And now, turning to our program, please welcome Angie Tornes, retired Senior Resource Planner for the National Park Service, to introduce our speaker.
Good afternoon. For the second week in a row, we have had experts from the University of Wisconsin-Madison grace our podium. Last week's topic was on the economy. This week's is on the environment, and specifically climate change. The confluence of these two topics would have pleased former US Senator Gaylord Nelson immensely, because he was famous for saying, the economy is a wholly owned subsidiary of the environment. And I'll repeat that. The economy is a wholly owned subsidiary of the environment. Rotarians worldwide have been working towards climate change solutions. Last year, Rotary International met with others and the United Nations to focus on the urgency of climate change and opportunities before the 2030 deadline United Nations has for achieving their Sustainable Development Goals. In addition, last year's Rotary Conference in Toronto, atmospheric scientist Catherine Hayhoe focused on applying the Rotary four-way test to climate change. And she concluded her presentation with 6 facts. And these facts were nicely summarized by Milwaukee Rotary member Mary Bullock, Environmental Committee member Mary Bullock. And these points are: climate change is real, it affects all of us, it is serious, experts agree on its validity, and we have a chance to get others to care about it, and there is hope if we talk about it. So to begin the conversation today, we have invited Steve Vavrus of the University of Wisconsin's Climate Change Office at UW-Madison. The office provides climate services to stakeholders across Wisconsin. And Steve is an expert not only in Wisconsin's climate, but also in global climate change and severe weather and the Arctic climate. Steve grew up in Indiana, and he experienced, growing up, tornadoes, heat waves, blizzards, and these things influenced him to become a climatologist. He spent his undergrad as a Hoosier, but then elevated in status to become a Badger, and then pursued his master's and PhD here. He's wisely decided to live here with his wife ever since. Please welcome Steve Vavrus.
Thank you for that introduction, Angie, and thank you to Rotary for letting me come here to talk about one of my very favorite topics in the world, and that is Wisconsin's climate. So without further ado, we will move forward here. And this is when, in any talk, it's important to convey why this should matter. So of course Wisconsin climate matters to me, right? That's my whole profession. But why does it matter? Why should it matter to ordinary Wisconsinites? And I would argue that the climate shapes our state every day and in ways that we don't even think about. And I'm going to go through some slides to make this point. So if we go back 20,000 years ago, the mother of all recent climate changes in the geologic past was taking place. So this is how Wisconsin looked 20,000 years ago. Would have been a chilly Rotary meeting down here under the Lake Michigan ice lobe. And you can see that roughly half the state was covered in thick ice. And so this sets the stage for where lakes are predominantly in the state, for example. And notice a couple other features. The driftless area where the glaciers never reached, and then Glacial Lake, Wisconsin, here in the middle of the state, which then I'll get to in a moment what happened to it. But these are some of the features that affect our climate and our lives even today. One example, the driftless area. So because the glaciers never reached the driftless area, it has a very characteristic landscape of rolling hills, valleys, rivers, and so on. Really beautiful, right? We love the driftless area. But that's why, because the glaciers didn't reach it. But where glaciers did reach, and I'm including my home state of Indiana, it's rich, fertile farmland, including much of Wisconsin and the entirety of the Midwest. So it was Canada's loss, this rich, fertile soil that was transported by the glaciers all the way down here and creates a vibrant agricultural industry for us. The Wisconsin Dells. This is an iconic image of the Wisconsin Dells. Most of us have been there. This looks very familiar. But the reason why we have these beautiful sandstone features is because glacial Lake Wisconsin burst about 15,000 years ago with the retreat of the ice sheets. And as a result, we have this beautiful place to go at the Wisconsin Dells. And of course, we can't forget our home field advantage with the frozen tundra. Look at those guys having fun playing in cold weather. Green Bay has the coldest venue for an outdoor stadium in the country, and we don't want to lose that home field advantage, do we? Economically, it affects our climate change in the past, affects our lives every day. Wisconsin is the third biggest potato grower of any state in the country, and a large reason why is because we have great sandy soils to support it. And in particular, look at the middle of the state there. That's right where glacial Lake Wisconsin used to be, and that provides a lot of excellent sandy soils for potato production in particular. Another example, fourth biggest maple syrup state in the country, largely because we have this favorably cool climate and soils that support maple trees, sugar maples especially, particularly in the northern part of the state. And then one of my favorite places in the world, Door County, one of the reasons it's a big fruit growing area is because of the buffering effect of Lake Michigan. So it's slower to warm up in the spring, slower to cool down in the fall. Trees like apples and cherries love that, and so what's one of the reasons why Door County is known for its fruit production. So those are some climate changes in the past that are still affecting our lives every single day. But now, what about where we are today and where we've been in the more recent past, say the past century or a few decades, and where is it going in the future? So another argument, climate change in Wisconsin is important because it's changing and affecting our lives. I'll give some examples of this. One of the things that's been happening more and more lately, and it's been in the news, is that we're having more expensive weather disasters, not only in Wisconsin, but around the country. And this graph really encapsulates that. These are so-called billion-dollar weather disasters, so $1 billion or more dollars. And NOAA keeps track of this all the way back to 1980. So when you look at this graph, what you're seeing is the number of these billion-dollar weather events, that's the bar, and the color coding shows the type of event, whether it was a drought or a flood or an ice storm or so on. You don't need to be a climatologist to see the upward trend here, right? Particularly in the last decade or so, we've really gotten to a peak to the point where we had record numbers of these expensive weather disasters in 2023 and again last year, 2024. And if you look carefully at this graph, you'll see the color coding. I've highlighted the green for severe storms because that is the component of these weather disasters that explains the overall rise. We're getting more and more of these extreme severe storms, tornadoes, windstorms, hail, and so on, and that's contributing the bulk to the upward trend. Some of this increase may be because we're making ourselves more vulnerable. Maybe we're building in expensive places when there's a storm. But we can even look at the trend in the extreme weather itself. So that was kind of a proxy for extreme weather, but we can look at the trends in the extreme weather itself. Our state climatology office has put together what we call an extreme weather index, going back to the 1890s. can get into the guts of this if you're interested after the talk, but basically it's a measure of how much the temperature and precipitation deviated from the long-term average over time. And what we find is this increase by county since 1895, color-coded so that the darker colors indicate a bigger rise in extreme weather. And if you look carefully, you'll see all counties are showing an increase. Statewide, there's been a substantial 25% increase over time. And it's the southern part of the state that's seen the biggest increase. The poor folks in Dodge County have seen over a 50% rise. And the peak of this index occurred in the 20-teens decade. And as we'll see why, that's because it was especially warm and wet. If you think of two words that describe climate change in Wisconsin, it would be warmer and wetter. Those two words describe the past and mostly where we're heading in the future. What I'm showing here is a graphic showing the decadal average temperature statewide, starting in the 1890s and proceeding through the last complete decade of the 20-teens. And you can see in the bar graph that it's been going up, but not consistently. Here's this peak in the 1930s, the Dust Bowl. That was the warmest decade on record in our state until the 90s came along. But the 2000s and the 20-teens have been the warmest decades on record so far. However, we are halfway through the 2020s now, and I was curious where we stand at this point, this decade. And I was surprised to see that we are all the way up there. We are literally off the chart so far for half the 2020s. And granted, we have half the decade to go, but that gives you a sense that we're already shattering the two warmest decades on record by quite a bit. So that's the statewide average, but we can also break it down regionally because we don't live in the statewide, we live in a particular county. What I'm showing here is the breakdown or the trends in temperature by season. So we've got winter, spring, summer, and fall for every county starting in 1950. So not as far back as the other one, but still 75 years worth of a trend. And what you see is that the warm colors indicate a warming trend, and the warmer oranges and reds indicate the biggest warming trends of all. So if you look by season, you'll notice that winter is the season that's warmed the most around the state, in almost every county. Spring and fall are very similar to each other, not quite as much, but about 3 to 4 degrees Fahrenheit warming compared to about 6-7 degrees warming in winter. And then summer is the season when we've warmed the least. Still, every county and every season has warmed, even in summer, but summer has warmed the least. Winter has warmed the most in Wisconsin. Now I want to kind of focus on that winter warming, partly because it is winter right now, but also because that has the biggest signal in the trend. We have put together in the State Climatology Office this record of the coldest temperature anywhere in the state going all the way back to the 1880s in this case, 1885. And that's what's shown here. The blue curve represents the value in a given year, and the black curve is just a running average. So I want you to look at this for a moment, because these are some really cold temperatures. I'm going to focus here on minus 40. And take a look at how often we fell into the minus 40s, even the minus 50s in Wisconsin in the past. And now, over the past, since about the middle 1990s, only once have we dropped below minus 40. Pretty remarkable. So over the last 30 years, the extreme cold has gotten less extreme in Wisconsin. So when you hear an old timer talking to you about how cold it used to be back in the day, you should believe them, because they're telling the truth, and that's what this graphic is showing. And this has implications for Milwaukee, for example, and those who live along the Great Lakes. The warmer winters have meant less ice cover on all the Great Lakes. We've seen that in the record. And in particular, we see fewer frozen days going back to the early 1970s right here on Lake Michigan, about 3 weeks fewer. And so that is one example of what's happening, or an impact of the warmer winters. But there's another impact too, as we saw around here. If you remember back to 2020, not the pandemic part, but just before, in late January of 2020, there was a big storm that kicked up around the southern Great Lakes, and a combination of strong winds, a really high lake level, and low lake ice cover combined to create these big waves and a lot of shoreline damage and property damage right here in Milwaukee and adjacent counties. So this is another societal impact that we've seen from the warmer winters around here. Now, the other part of warmer and wetter, of course, is wetter. And on the right is showing a similar kind of graph, but this time showing the average annual precipitation in Wisconsin. Again, going back to the 1890s. One thing you notice once more is the dryness in the 1930s Dust Bowl. You see that little dip in the middle of the graph. But what's really stands out is the peak in the 20-teens. We shattered the all-time record for wettest decade in Wisconsin in the 20-teens, and it wasn't even close. So far in the 2020s, you can see on the very edge there, the green, we're still relatively wet in the 2020s, not quite as much as with temperature, but still among the top 3 decades so far. So the warmer and wetter trend has persisted. Again, if we break down the precipitation trends by county, just like we did with temperature, we can see that the winter, once more, is the season where we've seen the biggest changes. All those green colors indicate increases in precipitation, this time around 20% since 1950, affecting almost every county. Spring also getting wetter in our state, not quite as dramatically as winter. Similar trend in fall, getting wetter. Summer is more interesting. You see it all depends where you are. If you're in the central and southern parts of Wisconsin, definitely been getting more rainfall, about 20% more. But the farther north you go, the trend changes, and there's actually been a drying trend in northern Wisconsin. So quite different in summer compared to the other seasons. Keep that in mind. Those 20-teens were important because we didn't just have a lot of precipitation in small doses that added up to a lot. When it rained, it poured. And here you see the number of so-called 100-year daily rainfalls in the 20-teens. These are rainfalls that are so uncommon that we would expect them to occur only once every century. But we had over 20 of these in Wisconsin, and you can see that it affected all parts of the state, north, south, east, west. And if you look carefully, you can see the amounts that fell, with the highest amounts being just under a foot in western Dane County in 2018. And what 100-year rainfalls can do is this. These are pictures of infrastructure damage from some of these floods all around Wisconsin, and there was even one fatality in Madison from that heavy rainstorm in 2018. But I shouldn't be telling this group about extreme flooding, right? Unfortunately, you have lived through it very, very recently, more dramatically than those pictures. In fact, the record flooding here in the Milwaukee area in August was staggering. This was considered a 1,000-year rainfall event, so expected only once every millennium. And it is going to go, you can see the amounts here in the radar depiction, 8 inches or more over a big area. It is going to go down as a new statewide record for most rainfall in a 24-hour period. So we're putting the final touches on the official notification, but it's going to be this 14.5-inch bullseye over at Madison High School over on West Florist Avenue. Does anyone live or work near that area in this group? Yeah, okay, so my sympathy, because you really were ground zero for this storm, and I know a lot of people in Milwaukee had flooded basements or worse. At this point, the price tag is $76 million, and it probably will climb further. So really, really major event very recently. So that's what's happened in the past, but we can't change it what happened. We can learn from it. These stress tests are useful for telling us where we have vulnerabilities in the system, but we now want to turn to both the future as well as organizations that can help better understand climate change and its impacts. So I'm going to be introducing two organizations that Angie pointed to at the introduction, one being the State Climatology Office and the other being WICCI, Wisconsin Initiative on Climate Change Impacts. So first of all, the State Climatology Office, I'm the director of it. We're at UW-Madison. Our mission is what we call climate services to help people use weather and climate information most effectively. But no one knows what the heck climate services are, so I have to give them the three I's. Climate services encompass information, especially reliable information, interpretation. So even though you might find reliable climate and weather information, it can be technical. It may be hard to apply to your problem, and so we serve as consultants or translators. And then the final being investigation, research, basic research, applied research to better understand Wisconsin's climate. Now, importantly, our office's focus is on the past and the present. So things like the Milwaukee flood, things like, the coldest temperature of the year back to the 1880s, that's really our purview. For the future, we turn to our partner organization, WICCI, which is a partnership itself between the Wisconsin DNR and the UW-Madison Nelson Institute for Environmental Studies. WICCI has been around for nearly 20 years now as a statewide organization, and it really sits at an interface between the science of climate change and then the adaptation to climate change. What can we do about some of its impacts? So we sit at this kind of as a catalyst, and we have a very practical mission. We're working to generate and share information to foster solutions. So how can we better cope with the changing climate? WICCI is best known for our assessment reports that come out every 5 to 10 years. The last one was about 5 years ago, and I want to let you know we're going to have a new report coming out early in 2026. So that'll be the state-of-the-art assessment of Wisconsin's climate trends, and some strategies and solutions for how to cope with it. Future. I mentioned that WICCI's purview is largely the future, and what is our future going to look like in Wisconsin? Well, I think, like a lot of climatologists, that we're going to be seeing the same kind of trend, wetter, warmer, and then generally wetter. I'm going to say one exception for the wetter part, as I'll show in a moment. But warmer throughout the year, warmer in every county, and one of the consequences we're likely to see is more extreme heat in our state. Here's an example of showing that shows the expected trend by late century. So this is like the 2080s, 2090s period, so about 70 years from now or so, of 90-degree or hotter days. So I think most of us would agree that 90 degrees is pretty hot around here. And fortunately, because we're a northern state, we don't get a huge amount of 90s. We're not like Phoenix, but we do get our handful. If you look at the past on the left, this is the average number of 90-degree days in Wisconsin. So typically about a handful down here in southern Wisconsin. But based on a lot of different climate model projections that we've analyzed, we think that that's going to change dramatically in the future. On the right is the projected change in 90-degree days, or the number of 90s that we should expect annually. And you see it's a very red-looking state, which indicates anywhere from 35, so 5 weeks or more of 90s. The statewide average up here is 59, so about 2 solid months of 90-degree weather if these expectations of greenhouse warming materialize. Now, this is a mid to high-end carbon emissions scenario, so we're not tied to this, but the models are saying that if we continue on this path, this is the kind of heat we might be expecting. And Milwaukee in particular, like other urban areas, is really susceptible to these heat waves. As many of you know, the middle of cities tends to get hotter during the same kind of heat wave that affects a region. A good example of that, for which we have data, is a heat wave that occurred just 3 years ago. This is a July 2022 heat wave in which a lot of citizen science volunteers went around with thermometers all across Milwaukee and by the block measured the temperature during this heat wave. And what they found was indeed the urban heat island was alive and well in this heat wave. Here's a graph showing the evening temperatures during the peak of that heat wave. The bright red is 88 degrees, so really warm for an evening temperature, and the blue colors are about 10 degrees cooler, so much more comfortable. If you look at this map, you'll see that, boy, the reds are really concentrated in the center of the city, right? And then as you get north and south and a bit west, you see cooler colors. And in some places, in some cases, there is a really sharp distinction between them, even from one street practically to another. And the reason why we're getting this excessive heat in the middle of the city is largely because there's minimal green spaces there. So there's asphalt, there's buildings, there's sidewalks, there's streets. All of those surfaces really absorb the heat during the day and retain it at night. And we know from health experts that it's really important that people be able to cool at night during heat waves, or else that heat really wears down the body and can lead to excess mortality. So this is both a concern, but also potential for solutions. A lot of this can be alleviated with more green spaces, more tree planting and parkland. The future for precipitation, it's a little more complicated than the story for temperature. Our climate models are saying that by late century, the winters should continue to get wetter just as they have been. The springs should also continue to get wetter, and the falls should get wetter as they have been. So overall, that leads to a generally wetter Wisconsin future. But one exception now, the newest climate models are suggesting that the summers will become drier by about 10 to 15% across the state. That is kind of a new result. The older climate models were equivocal about the summer rainfall change, but it does appear now that the summers will become drier, and that has implications for agriculture in particular, also tourism, water resources, and so on. So keep this in mind, a 10 to 15% change on average in our wettest season of all could be significant. One thing about a warmer climate is that it can hold more water vapor. So this is just basic physics. A warmer atmosphere can hold more water vapor, so when the conditions are right for a heavy rainstorm, more rain can fall. And that is the trend that we've been seeing, those 20 teens, 100-year rainfalls, for example, and it's also the trend we're expecting for the future. What I'm showing here is the frequency of rainfall days of 2 inches or greater. So certainly that August event here fit the bill, but even more modest ones of 2 inches or more are included here. And in the past, on the left, it's showing how frequently these 2-inch or heavier events occur. The scale on the right is the number of days per decade. And Milwaukee is roughly one of these events per year, 10 per decade, to put it in perspective. In the future, we're expecting a change, not so much in the spatial pattern. The heaviest, these events are more frequent in the south and the west of Wisconsin. That should continue, but the magnitude goes up. So the map becomes bluer. And in Milwaukee, for example, the models are suggesting that instead of these events happening once per year on average, they'll start to happen 1.5 times per year. So 5 more times per decade, which starts to add up if you're looking at infrastructure damage and flooded basements and so on. To conclude, and leave plenty of time for questions and comments, here are some of the takeaways for today. At the outset, I tried to make the point that climate affects us in a lot of ways we don't think about day to day, even these past climate changes that occurred thousands of years ago. I want to emphasize that the State Climatology Office and WICCI are both here to serve. So we are very much service organizations. We want to hear from you and find out how you need weather and climate information for your lives and your livelihoods, and we're happy to work with you on that. Warmer and wetter, I think I've impressed those words upon you enough today. Those are Wisconsin's climate trends in the past and also the direction we're heading in the future. And then in terms of the future, specifically in terms of the precipitation, it looks like we'll be seeing wetter winters, which could mean more snow, but it could also mean more winter rain. Wetter in winter and spring, but probably less summer rainfall. And then finally, much more extreme heat likely in the future, but at the expense of less extreme cold. So I didn't have time to get into the map of that, but we're certainly expecting fewer sub-zero degree nights, some of which we've seen already this month around the state. So less bitterly cold conditions, but more extreme heat expected in the future. With that, I will stop and be happy to take questions or comments. And you know the scene, how to do this better than I assume people go up to the microphone when they have a question. Yeah.
All right, questions?
Good afternoon, Tom Gale. Thank you for being here. As oceans fuel hurricanes, tell us about Lake Michigan and our climate.
Yeah, so warm ocean waters do fuel hurricanes. This is something that we've seen recently, these explosive intensification of hurricanes, especially in the Gulf. In Lake Michigan, we're fortunate, we don't get hurricanes, but the warm lake waters can definitely enhance storms. We get cyclones, those can spin up more rapidly, especially in the fall around here, and they can also be favorable for lake effect snow. For the same cold air mass passing over the Great Lakes, warm lake waters will enhance the lake snowfall. So that's very, very apparent. Thanks for that question.
Hi, Teresa Esser. I used to work for Kluwer Academic Publishers, which published the Journal of Climate Change. You're probably familiar with it. I am familiar with a lot of young people who are planning on being alive for decades, maybe even 100 years from now. And they often express a lot of concern about climate change, and they often want to know what they can do. For example, can they have a job that relates to working to save the climate? Are there jobs that help with climate change? What do you tell young people like that?
Yeah, so it depends what their interests are. If it's a career decision, I mean, renewable energy is booming, so that's a field to encourage people to go into. But in terms of, things that we can all do day to day in our lives, it turns out that reducing food waste is a huge lever on reducing climate change. Whether you're young or old, that is something that we can all try to do, and it's something that has benefits, economically as well as climatically.
Hello, I'm Antoine Carter. I have a quick question. That's why I'm here. Last week, someone came in and talked about the declining population in America, right? So does a declining population have any factor in the future of climate change?
Thanks for your question. So the short answer is yes. The longer answer is it's complicated. Typical scientist, right? So the reason I say that is because, ultimately it's the total carbon emissions around the world that matters. So, more people for the same per capita carbon emissions, the more total carbon we're putting in the atmosphere. But it's a sensitive point because an average American, an average European emits a lot more carbon than people in a lot of other parts of the world where the population's growing faster. So there's some trade-offs. And so I think we need to be careful in sort of making a blanket statement about population growth and climate change. They definitely are related, but you have to unpack it to really understand the important nuances. That's a great thing to bring up.
Hi, I'm Steve Einhorn. Very much appreciated your speech. There are numerous scientists who are not climate activists like yourself. There are none in Madison. Are you concerned with or doing anything about the fact that there's almost a complete lack of viewpoint diversity in your department?
In my department?
Well, in the climate change area.
Well, I would say there are different levels of agreement and disagreement on the topic. You'll meet very few climatologists who dispute the fact that the climate's warming and the ultimate cause for it. Where there's differences, and I think important differences that are valid, is what should we do about it? How important is climate change compared to other societal issues? How much will it cost? Who's going to pay the bill? And so on. So I think all of those are very solid grounds for debate and discussion, and I think that the forums like this are really good for that. Thanks.
Hi, I'm Mary Bolick. I noticed from the maps, it seemed like central Wisconsin was least impacted across the board. And if that's true, why is it?
You might be looking at that 100-year rainfall events. Central Wisconsin was pretty lucky right in the middle to escape those. I think I would argue that's probably just due to chance and good luck. If you looked at more decades, you'd probably see Central Wisconsin's not immune. But in terms of some of the warming trends, actually, depending on the season, Central Wisconsin was part of the overall statewide average, if not in some cases like winter, a little bit warmer still. Thanks.
Hi, my name is Milton Bond, and thank you for your presentation. It was informative. Thanks. My question is about the ozone. With the commercialization of the space and sending out satellites and rockets, and does that affect the ozone? Because to my knowledge, when you pierce the ozone, it doesn't heal. And therefore the sun comes piercing through and heats up the Earth, and that heats up the planet. So is that a cause that also heats up our planet because it doesn't heal itself? So basically, does that cause also heats up our planet? And is there something that we can do about it? To my knowledge, there isn't.
Yeah. So ozone has been a big topic over the years when it comes to climate and also ultraviolet radiation. So there's two different types of ozone, or two different levels. There's the ground level ozone, which is bad. It's bad for our lungs. It's also bad for the climate system. It causes additional warming. What you're talking about is the high level ozone, way up in the stratosphere. That has actually been a real environmental success story over the years. So chlorofluorocarbons from aerosol cans, it was recognized way back in the 70s, was causing that ozone shield that blocks harmful radiation from reaching our planet. That has largely healed, not completely, but we've gone a long way toward healing and curing that problem. So we're in the right direction on that, but if we hadn't, then yes, there would be additional radiation that could get through the atmosphere, heat the Earth, and enhance the warming trend. International agreements. The Montreal Protocol was an agreement to phase out chlorofluorocarbons that countries around the world agreed to, and there were readily available alternatives to these CFCs. Unfortunately, some of those alternatives ended up being greenhouse gases, we found out later, so there's a trade-off, but that's considered a very big environmental success story, the cleaning up of the ozone layer. Thanks.
Hi, my name is Hannah Paul. I was curious about your slide with the evening heat in Milwaukee and how Earth cities are the places where it can be hotter. I've been in Milwaukee for 12 years and I don't do data points of weather, but it always seems that Milwaukee is a lot cooler than Wauwatosa and Madison. Sometimes they're in the hundreds and we're in the 80s. Was that an outlier of a data point, or I'm just curious, and also what thermometer was everybody using?
Yeah, don't know the answer to that one. But Milwaukee's complicated in the sense that you're right by a cooling lake in the summer, right? So the lake breeze, you all know the lake breeze better than I do. But when that kicks in, Milwaukee, especially near the shoreline, can be much cooler than other parts of the city and even other parts of the state. And you know really better than I do in the spring how cold Milwaukee can be when there's an east wind in April and May compared to other parts of southern Wisconsin. So the lake does complicate it, but I think this particular heat wave that I was showing was one where the winds were light and the lake breeze did not play much of a role.
Hi, I'm Tim Hunter. Wisconsin has so many beautiful parks. What's going to happen to the flora and fauna in our state?
Yeah, that's a great question, and that's true not only of the parks, but also, you know, gardeners and farms and whatnot. So that's an active area of study, and there are people who are studying climate who understand that a lot better than I do, but it stands to reason that plants who are adapted to a certain type of climate, say south of Wisconsin, will tend to thrive more as we get warmer and wetter conditions, because pretty much as you do a transect due south, it gets not only warmer on average, say Illinois, but also wetter as we get closer to the Gulf of Mexico. So just do a simple projection, warmer and wetter in the future, whoops, that does translate into more of a climate typical of Illinois or even Missouri if it be warm and wet further.
Hi, Steve. Thank you. Great presentation. My name's Tom Lujak. Wisconsin is the dairy land. We've got a lot of cows here. Any idea what impact this warming climate will have on what is one of the key parts of our economy?
Yeah, absolutely. One of the projects we're working on actually is something called the Cattle Comfort Index. So we are working on an index with some cow physiology experts at UW-Madison to look at the combined effect of heat and humidity on dairy cows. And in particular, things like milk production, but also their comfort. And so it's a warning system. So by real-time measurements of temperature and humidity, we can inform livestock farmers of what kind of threat it poses to their cattle, as well as other livestock they may happen to have.
Hi, thank you. My name is Fred Bursch. If you go back to the slide, you had the 2-inch rainfalls or greater. There's a little spot in Ozaukee County that our club wants to take credit for. That's where we have our annual golf outing, and it rains every year. So you should point that out in future presentations.
Okay, will do.
With that in mind, how does Wisconsin compare to the rest of the country, the rest of the world, over the next 20 or 30 or 50 years? Is this the best place to stay, or is it time to migrate?
Yeah, boy, climate migration comes up in most public talks on climate change. We can oversimplify that. We can say, well, Wisconsin doesn't have hurricanes, we don't have sea level rise and wildfires and such, so it stands to reason that people might migrate here. If you talk to the population experts on this topic, they say, oh, hang on, it's a whole lot more complicated than that. And when people decide to move, if they move at all from an environmental stress like climate change, they typically don't move very far. If you look at the diaspora from Hurricane Katrina in New Orleans in 2005, FEMA has made a map of where people moved, and it's surprising how they didn't move very far. You know, they didn't move to Chicago and Seattle typically, they moved to Mobile or to Houston or to Miami, which if you're trying to escape a hurricane, those are not the top 3 choices on my list. So yeah, it's a complicated topic, but it's certainly one that's going to be in the discourse for the foreseeable future about whether Wisconsin and the Great Lakes will become a climate haven.
All right, last question.
Great talk. I'm curious, my name's Marissa Jablonski. I run the Freshwater Collaborative across system, and I speak to a lot of legislators about funding water, and so I'm curious what you're the director of a couple of organizations across Wisconsin, and I'm wondering, how do you speak to legislators who may deny the science, and how do we propel action and money going towards climate prevention? Obviously, you showed it's very expensive climate harm. Thanks.
Yeah, thanks, Marissa. So I did happen to speak to a group of congressional staffers just in the past month. All but one office came to this event, and I tried to make the argument of dollars and cents. This is a bread and butter issue in terms of our economy, dairy, farming, infrastructure damage and whatnot, these billion-dollar weather events, I mean, somebody's paying the bill. And so I think that it's, nobody wants to waste money. Everybody wants a thriving economy, just like nobody wants to waste food. So trying to find these sort of low-hanging fruit that we can all agree on, and then building from that. And then, there's always going to be areas of disagreement that we're going to have. But if we can at least agree on the first-order impacts and doing something about them, I think we can build a lot of political will. Thanks.